am Meghna Parekh, and today we are here to start a lecture series of Mathematics 2. Chapter is Laplace Transform and Lecture 9 Inverse Laplace Transform. In last lecture 1 to lecture 8, we have discussed about the Laplace transform and its property. Now, today we will discuss about the inverse Laplace transform. Inverse Laplace transform. If Laplace of f of t equal to f of s, then f of t is called inverse Laplace transform of f of s, and it is denoted by f of t equal to Laplace inverse of f of s, and Laplace inverse is called inverse Laplace transform operator. Some of the formula, like Laplace of 1 is 1 by s. So, Laplace inverse of 1 by s is 1. Now, Laplace of t raised to n is n factorial upon s raised to n plus 1. So, here Laplace inverse of 1 upon s raised to n, we are taking t raised to n minus 1, n minus 1 factorial. Similarly, Laplace of e raised to at is 1 upon s minus a. So, inverse of this e raised to at. Inverse of 1 upon s plus a, e raised to minus at. 1 upon s square plus a square is sin at into 1 upon a. 1 s square minus a square, it is 1 upon a sin hyperbolic at. S upon s square plus a square cos at, and s upon s square minus a square cos hyperbolic at, and inverse of 1 is delta t. Okay. So, find the Laplace inverse of 1 upon under root s. Now, Laplace inverse of 1 upon s raised to 1 by 2. Okay. So, what is the formula? It's look like 1 upon s raised to n. We have two type of the formula. One is factorial formation and second one is gamma formation. We are using here gamma formation due to the fractional part. So, this t raised to n minus 1 upon gamma n. What is the answer? S raised to 1 by 2, sorry. T raised to, what is n? N is 1 by 2 minus 1 upon gamma 1 by 2. 1 by 2 minus 1 is t raised to minus 1 by 2, and gamma 1 by 2 is under root pi. So, answer is 1 upon under root pi t. Okay. So, this is the inverse Laplace transform of the 1 upon under root minus s. First shifting theorem. What is the first shifting theorem for the Laplace? Laplace is Laplace of f of t. It is f of s minus a. If we are applying Laplace for the e raised to at f of t, we get f of s minus a. So, if we are applying inverse of f of s minus a, we getting e raised to at f of t. Similarly, for the second shift theorem, inverse of f of s equal to f of t, then inverse of e raised to minus as upon f of s, f of t minus a, u of t minus a. One example, find inverse Laplace transform of s plus 2 upon s square minus 4s plus 13. So, first of all, s plus 2, s square minus 4s plus 13. Okay. Now, see in denominator, there is no any formation to have, we have applied any type of the formula of the Laplace transform. So, we convert this form in the whole square form. What is a whole square formation? It is s square minus 4s plus 4 plus 9. We are taking part of the 13. So, it is s plus 2 upon s minus 2 whole square plus 9. We have s minus 2, so we set this formation in numerator. S minus 2 plus 4, s minus 2 whole square plus 9. Okay, so Laplace inverse s minus 2 upon s minus 2 whole square plus 9 plus Laplace inverse 4 upon s minus 2 whole square plus 9. Okay. Now this is the inverse first shift theorem. We are taking e raised to 2t as a common. So we get s upon s square plus 9 plus 4 upon s square plus 9. E raised to 2t. Laplace inverse of s upon s square plus 9 is cos 3t, and it is 4 by 3 sin 3t. So this is your answer of this example. Now we are revise this example due to we are using here inverse first shift theorem. What is a first shift theorem? What is the first shift theorem? First shift theorem steps, we have first find Laplace of f of t, and due to e raised to at, we are convert s to s minus a. So in inverse first shift theorem is vice versa. We have s minus a formation, we are converting into s. To convert this s, we are multiplying with e raised to at. And after that we getting f of t and we are f of s, and we are applying inverse of s. Okay. So what we do here, see, s plus 2 s square minus 4s plus 13, s plus 2. We are taking 13 part of the 13, 4 plus 9. So it is s minus 2 whole square plus 9. Okay. It is s minus 2 whole square plus 9. So we set the formula of the s minus 2 in the numerator. We get s minus 2 plus 4, s minus 2 whole square plus 9. Taking individually s minus 2 upon s minus 2 whole square plus 9 plus 4 upon s minus 2 whole square plus 9. This formula is look like a s and s square plus 9, but we have s minus a formation, and if we want to remove s minus a formation, we have applied inverse first shift theorem. What is inverse first shift theorem? Inverse first shift theorem say that take s minus a to s, s minus 2 to s. For that case, you have to multiply with the e raised to at formation. So what is a? A is a 2. Taking e raised to 2t, Laplace inverse is, we are converting s minus 2 to s, s upon s square plus 9, 4 upon s square plus 9. Now, inverse of s upon s square plus 9 is cos 3t, and inverse of 4 upon s square plus 9 is 4 by 3 sin 3t. So this is the answer. Next, find the Laplace inverse of e raised to minus 3s upon s square plus 8s plus 25. Okay. Now it's look like e raised to minus as f of s. Okay. So first of all, this is the second shift theorem, and answer is f of t minus a, u of t minus a. Okay. Now, first of all, we are comparing this formation e raised to minus 3s upon s square plus 8s plus 25. So answer is f of t minus 3, u of t minus 3. Okay. But what is the inverse of f of s? Inverse of f of s is 1 upon s square plus 8s plus 25. To find the inverse of this, how to find the inverse of this? We are cover the whole square, s square plus 8s plus 16 plus 9. Okay, so it gives Laplace inverse 1 upon s plus 4 whole square plus 9, and inverse of this is e raised to minus 4t divided by 3 sin 3t. inverse first shift theorem, due to s plus 4, we are taking e raised to minus 4t, 1 upon s square plus 9. As a formula, we are taking 1 upon 3 sine 3t. Your formula. Now, this is your actual f of t formation. So, we replace in this form. Answer is e raised to minus 4 t minus 3 upon 3 sine 3 t minus 3 into u of t minus 3. Okay, we are taking again this form. What is inverse second shift theorem? Is e raised to minus as f of s. Okay, and answer is f of t minus a, u of t minus a. Laplace inverse of e raised to minus 3s upon s square plus 8s plus 25. We get f of t minus 3, u of t minus 3. Now, what is the f of t minus 3? We have to find from the f of s. So, we are taking f of s, Laplace inverse of f of s. Laplace inverse of 1 upon s square plus 8s plus 25. We are taking the parts of the 25. 1 upon s square plus 8s plus 16 plus 9. So, we have 1 upon s plus 4 whole square plus 9 form. But see here, we have actually in the formula, as per the formula, we have here s formation, but we have the s plus 4 formula, so we are converting s plus minus a or s plus a to s. To that, we are applying inverse first shift theorem, e raised to minus 4t. Is s square plus 9. E raised to minus 4t. 1 upon s square plus 9 is 1 upon 3 sine 3t. Okay. Now this is your f of t. Put this value in this. So, our last answer is e raised to minus 4 t minus 3, because f of t minus 3 upon 3 sine 3 t minus 3 u of t minus 3. Okay. Next example. Find inverse Laplace transform of 3 1 minus e raised to minus pi s upon s square plus 9. Okay. Laplace inverse of 3 upon s square plus 9 minus 3 e raised to minus pi s upon s square plus 9. Okay. See, both example are different. We are taking here, it is I1 and I2. Now, for I1, Laplace inverse of 3 upon s square plus 9, answer is sine 3t. For I2, I2 is inverse second shift theorem. So, it is 3 e raised to minus pi s upon s square plus 9. This f of t minus pi, u of t minus pi. Now, to find the f of t, what is our f of s here? It is 1 upon s square plus 9. 3 upon s square plus 9. So, f of t is sine 3t. Now, we put the value in function. We get sine 3 t minus pi u of t minus pi. Now, last answer is I1 minus I2. So, answer is sin 3t minus sin 3t minus pi u of t minus pi. This is your last answer.